is part 4 for chapter 9. This is the last chapter of this tutorial. We will create our interesting the 3D heart shape here. So this, if you look at this shape, it's not easy. You can do that through our 2D, the square or the circle to make the cutting, and also not easy to use the polygon directly by all those the points one by one. But we can use some calculation from the mathematics way to achieve this. So let's go to here. So create this polygon and the mass to do this. So first is we, if we see the way is to create this the shape. Actually, we can use the sine and the cosine combination. So on every point, x is you can give a t. T is this distance between from the this origin. Then you have this sine. This is the angle. Then when you have this the sine angle and with this the 3 power, and then the times 16, then you can define the value in the XXL. And also you here is the formula for the YXL. It's kind of complex, but that is the mathematical way for us to make this point, the heart. Then is to represent these two formula. Actually, is you are putting this is x, that is y. So what we are going to do is we let's make our file. Let's starting to play on this. So that is our part 4 heart. So we have our step first, then is we will make this t divided by this step. So that is the point. So if we see here, let's see. So heart. So let's give some the comments. Is x is the times 16 times sine t with the power. So that is the way we use this power. And the y is 13 times cosine t. That is the first one, minus 5 times cosine 2 times t, and then minus 2 times cosine 3 times t, then minus cosine 4 times t. Then we can have this, there's nothing, so syntax. Let's see what's the arrow. Heart line 1. Arrow, syntax arrow in file. Looks like there should be no arrow, so we don't put any code here. So there's arrow, let's syntax arrow in part 1, line 1, but there's no arrow message. So let me write down. Okay, that's the earliest arrow. Then we have our points. So the points. Point x. Let's make our perimeter. So if we see here, so t, let's make our t. So t is the equal to 4, t equal to 0, step. So that means is we should define a step first. Step, let's define. If no differences, we will have a step as the 1 by default. But we want to see how the accuracy we need. So we define our 500, and then this will be 300 divided by n. So that is our the step. Then we have this on our the code. So T is has this for loop. Then we have our X is this one, and then Y is this one. Ensure you should have this and another one. So let's see, we have a lot of warning. Let's see what is warning. Ignore unknown. So that means is I have one wrong parameter. So COS. So now there's no warning. That's perfect. Well, what we need to do is we will use this point to our polygon points. So that should be our 2D part. That's perfect. And what now we will do is we define a height. Height is 10. Then the only thing is we will do our linear. Height, extrude is h. Then that should be coming. And then this modify above script, so the outline is just a 20 point. So 20 point is defined by this n. So now it's 20 point. And then we see we have 100 point. So 500 is smooth enough. And remember is we have the parameter here. So you can also make some like this. We have a scale. Maybe we put this 0.8. Then what you will see, so it's from bigger to small. Let's make this higher. And then you remember we also have a twist. Twist, you can give our angle. So let's say I want that change to 45 degrees. Then you can see this heart is rotate and also shrink from big to small. So that is the thing is we are playing on those. And then in the next part is we will do some the auto-generate files, the list, and then we close on this the nice truck, nice car model update. See you then. Hello, welcome back. We will move to this last part for Chapter 9. Make this aerodynamic spoiler adding to your racing car. So let's go to here. First is we will make a little exercise for you. Is this is our quick list generation practice. So we finished this in the last part. So let's create a new file and save that as the part 4 second. So let's just record this as the auto list. Quick list generating. So how you can generate a list here? So like is I want this 3 list generate. So first one is you can see x equal to 4, I equal 1 to 6. Then assign that to y. That is not this parenthesis, is this one. So nothing generate. Remember, is we can have echo x. So now let's see here, echo x with this semicolon. So here echo 1 2 6 1 2 3 4 5 6. So that means is you can have a for loop to help you auto generate something and give that number to or some value. So same as this y equal to 4, I equal to 10. Now it's minus 2, but every part, the step is also minus 2. So we come to minus 2. So if you don't have our step is 1. So that means that this is the same. And then that's I and echo y. Let's run. So you got this 10. And then you go to 10 minus 2 minus 2. So the reason I got wrong is I should use the wrong the syntax. So it's you should have this this way to make the column is should be between these three or among these three figures. Then that is the way you create that, and you can create the two-dimension list. Let's see, Z is equal to 4. So first is I equal to from 3 to 6. And then the second value is 10 times of this one. So if you find that the pattern, definitely you can use 3, 4, 5, 6. Is step is 1, go to 6. That is the syntax. And then you get our list. I is the first, and I times 10 is the second. Then is this. Then let's echo Z. So now you can see here, you can use echo to just verify what you get. So that is the thing is we finished the last part, and the reason for that is we will have something is you can auto create these for this your heart coordination. You can create a function, then use this function to make your heart. So that is the thing is I want to mention this again. So for this video, we continue finish those details. So we back to our heart. So let's open the heart and save. Save as 3. So we will have the different the heart function. Then what we will do is we will introduce the function. The concept function is this heart coordinate is equal to this. So that is this part. So we will introduce our function heart coordinates is a point to t. So when we have this function, we can put that in the beginning. Then later on, we will call this function. So here So function is this one, and within here, we will use this one to replace this. So now your code is getting the easier, or let's see, we will have our just 20. So you can see your heart is still working to put that, and then this we can also have our this code to have more function. So then we have another function hard points, then equal to 50. Then what that means is this function actually is doing this points calculation. So that is the 4. Give a list finally. So, and then what we will call is points. It's just the hard points n. So hard points n equal to n. And then we have a linear. Height is height. We don't do this. Then you can see is age. And let's see what's wrong. So number 14 points. No, double semicolon. And then unknown hard points. So here, missing our heart is our T. So then you can see you got the same. The heart is rendered. And what's the one more thing is module heart age equal to 10 and n equal to the 50. Then we can put this as our module. So point this one, then we can starting to call the modules. So that is the one more thing. We call module heart age equal to 10 by default, n equal to 50. Then we put this heart inside, linears also inside, and then nothing. We will call heart. It's coming. So now it's using this default value. Or we see I want this age is 20. Then you get your customized heart. So this with this additional video, we finish this part 4. Next video, we will go to this real this car. See you then.